It weighed 200 tons, liquid, 3,000 degrees. And when it came back out of that furnace, it didn't pour, it exploded. 30 tons of molten steel turned into a fountain of fire that carved across the casting floor at Homestead Steelworks like the hand of God dragging a finger through hell. 11 men died in seconds. Some of them were hit so fast they didn't have time to scream. Others had time. You could hear them from half a mile away. This wasn't a mistake. It wasn't sabotage. It was physics meeting desperation, meeting profit, and the men standing in between paid the price in full. We're going back to August 7th, 1907, Homestead, Pennsylvania, the day the beast bit back. And before we're done, you'll understand why those men didn't have a choice and why they never stood a chance. When steel learned to flow, 1890. America's got a problem, a big one. The cities are growing vertically now. Skyscrapers punching toward heaven in New York and Chicago. Railroads are spreading west like veins across the continent's body. Bridges need to span rivers that laughed at wood and stone. The Navy wants battleships armored thick enough to stop artillery shells. And every bit of it, every single beam and rail and plate, needs steel, not iron, steel. But here's the trouble. Nobody can make enough of it. You've got the Bessemer converter, loud, fast, violent, blows air through molten pig iron, burns out the carbon in 20 minutes, dumps out 30 tons of steel while it's still glowing white. Sounds perfect. Except Bessemer steel is inconsistent, high in phosphorus, brittle in the cold, fine for rails, maybe, but you don't build a 50-story skyscraper on maybe. Then there's crucible steel. Beautiful stuff, pure, controlled. You can make blades sharp enough to shave with, springs that'll last a century. But you're making it 50 pounds at a time in clay pots, and it takes days. You want to build a bridge? You'll need 10,000 crucibles in 10 years. The country doesn't have 10 years. So somebody needs to figure out how to melt 100 tons of steel at once, hold it at 3,000 degrees for hours, control the chemistry down to fractions of a percent, and do it without blowing the whole operation into the stratosphere. Enter the open hearth furnace. The principle came from Europe. German engineer named Carl Wilhelm Siemens, French metallurgist named Pierre-Émile Martin back in the 1860s. Regenerative heating. You burn producer gas mixed with air, but before you waste all that heat out the flue, you run it through chambers packed with brickwork. The brick soaks up the heat. Then you reverse the flow. Fresh gas and air come in through the hot brick, preheated to 1800 degrees before they even reach the burners. Now you're not just burning gas, you're burning superheated gas, and that gets you north of 3,000 degrees Fahrenheit, hot enough to melt iron, scrap, ore, anything you throw at it, and hold it there, long enough to cook it perfect. By 1907, Homestead Steelworks, Andrew Carnegie's monster on the Monongahela River, 8 miles downriver from Pittsburgh, was running open hearth furnaces the size of houses. Each one could melt 200 tons of steel in a single heat. 200 tons! That's 400,000 pounds of liquid metal at temperatures that would vaporize bone. They called the open hearth shop Hell's Halfacre. And the men who worked there? They weren't wrong, but let's be clear. This wasn't about elegance. It was about scale. America needed steel faster than the old ways could deliver, and in quantities that would have been science fiction 20 years earlier. The open hearth furnace was the answer. Not because it was safe, not because it was easy, because it was the only thing that could do the job. The Bessemer was faster, sure, 30 minutes versus 10 hours, but you couldn't control it. The open hearth let you sample the melt, test the chemistry, add a little manganese here, a little carbon there, cook it until it was exactly right. High-quality structural steel, consistent, reliable, strong enough to hold up a skyscraper or armor a warship. By 1907, open hearth furnaces were producing 40% of American steel. By World War I, it'd be 70%. This was the workhorse, the beast that built the 20th century. And it was hungry. Carnegie had built Homestead back in 1881. 26 years later, it was one of the biggest steel mills in the world, stretched for miles along the Monongahela. Blast furnaces on one end, converting iron ore into pig iron. Open hearth furnaces in the middle, turning that pig iron into steel. Rolling mills on the other end, shaping the steel into whatever America needed. The place ran on immigrants, thousands of them. Men who'd crossed the ocean with nothing, heard there was work in Pittsburgh, and showed up at the gates. Most of them couldn't speak English, didn't matter. You didn't need English to shovel coal or haul scrap or stand in front of a furnace for 12 hours. U.S. Steel, the trust that had swallowed Carnegie's empire in 1901, didn't care where you came from or what language you spoke. They cared if you could work. And if you couldn't, there were 50 men behind you who could. So the Slovaks and Poles and Hungarians took the jobs, worked the shifts, sent money home to bring their families over, built lives in company houses on company streets, shopping at company stores, living and dying by the company's rhythm. And that rhythm was brutal. Hell with a roof in it. You want to understand what happened at Homestead, you need to see the machine, not as a diagram, as a living thing. Picture a building 100 feet tall. Inside, a rectangular chamber 20 feet long, 15 wide, maybe 8 feet high. The floor of that chamber, the hearth, is lined with magnesite brick. Special stuff, has to be. Ordinary brick would melt at these temperatures like butter on a griddle. Above the hearth, an arched roof. Also brick. Radiant heat pours down from that roof onto whatever you've loaded into the furnace. Below the hearth, 2 massive chambers filled with checkerwork brick, the regenerators. Gas burns in the furnace. Exhaust flows down through one regenerator, heats the brick white hot. Then, every 15 minutes, valves reverse. Now the fresh gas and air flow through that white-hot brick, picking up the heat, entering the furnace already screaming hot. That's how you hit 3,000 degrees and stay there. Feed it producer gas. That's coal turned into flammable vapor. About 50% carbon monoxide, hydrogen, a little methane, all of it ready to burn. Dangerous as nitroglycerin if it leaks. One spark in a pocket of accumulated gas, and you've got an explosion that'll level the building. The gas came from the coke ovens, batteries of brick chambers, where coal was baked in the absence of air, driving off the volatile gases and leaving behind nearly pure carbon. The gas was piped to the open hearth shop through hundreds of feet of iron pipe, hot, pressurized, lethal if it leaked. Men died just from breathing it. Carbon monoxide has no smell, no color, no warning. You'd feel tired, sit down for a minute, and never wake up. Now, you want to make steel. You start by loading the hearth. Pig iron, crude iron from the blast furnace, high in carbon. Scrap steel, old rails, worn-out machinery, whatever you can find. Limestone for flux. Iron ore if you need it, all of it solid. Cold, relatively speaking. You've got a mechanical charging machine, basically a rail car on tracks, that pushes a buggy full of scrap through the charging door and dumps it onto the hearth. Light the burners. The gas ignites with a roar you can hear a quarter mile away. Inside the chamber, it's not fire anymore. It's something else, a wavering, shimmering violence that doesn't flicker. It just is. The temperature climbs, 1,000 degrees, 1,500, 2,000. The scrap starts to glow red, then orange, then yellow, then white. And then it's not solid anymore. The metal softens, sags, collapses into a puddle. The puddle spreads, merges with other puddles, becomes a pool, a shallow lake of glowing liquid steel, 2 inches deep in some places, 6 inches in others, rippling like water but infinitely heavier. The surface shimmers with oxides, black slag floating on top, lighter than the steel beneath, forming patterns like oil on water. You're not done, not even close. Now you start refining. You need the carbon content exact, too much, and the steel's brittle, too little and it's soft. You need phosphorus below 0.04%, or the steel will crack in the cold. Sulfur below 0.05, or it'll be weak and porous. So you sample. A worker, the melter, extends a long-handled ladle out over the pool, dips it in, pulls out a spoonful of molten steel, pours it into a mold, lets it cool just enough to solidify, runs it to the chemist. The chemist tests it, sends back numbers. Too much carbon, add some pure iron, not enough manganese, toss in 50 pounds of ferromanganese. This goes on for hours. Sample, test, adjust, sample, test, adjust, all while standing 6 feet from a pool of liquid metal at 3,000 degrees. And here's the thing, nobody tells you about 3,000 degrees. It doesn't feel like heat. It feels like pressure, like something pushing against your skin, trying to cook you from the outside in. The air itself is wrong, shimmering, tasting like metal and sulfur. You breathe it and your lungs hurt. Your eyes water constantly from the ultraviolet radiation. The radiant heat bakes your face until the skin cracks and leathers, and that's just standing near it. Now add this. The open hearth shop at Homestead wasn't one furnace. It was a row of them. 6, 8, maybe 10 running simultaneously. Each one a miniature sun. The ambient temperature in that building in August, in Pennsylvania summer heat, hit 140 degrees Fahrenheit. Men passed out from heat exhaustion on their feet, drank gallons of water per shift, and still pissed dark because their kidneys were cooked. But you can't stop. The furnace runs continuously. If you let it cool, the refractory brick can crack from thermal shock, and you've got a $250,000 rebuild on your hands. So you keep feeding it, keep sampling, keep adjusting. The economics were brutal. Each furnace represented hundreds of thousands of dollars in construction costs. The refractory brick alone, specially formulated magnesite that could withstand 3,000 degrees, cost a fortune and wore out in weeks. Every hour the furnace sat idle was money lost. So you ran it hard, pushed it to capacity, squeezed out every ton of steel you could before the brick gave out, and you had to shut down for relining. And the men? They were cheaper than the brick. 10 hours in, maybe 12, the chemistry's right. Time to tap. There's a hole in the furnace wall, plugged with clay. A worker, using a long steel bar, punches through the clay. The molten steel pours out like water from a dam, flowing into a ladle the size of a small house. 20 tons, 50 tons, 100 tons of 3,000-degree liquid fire pouring out in a glowing stream that lights up the entire shop. The ladle, suspended from an overhead crane, is transported to the casting pit. There, the steel is poured into ingot molds, cast iron boxes standing upright. The molds fill from the bottom. The steel rises, glowing yellow-white, throwing sparks, radiating heat so intense you can't stand within 50 feet without protective gear. And when it's done, you've got steel. 200 tons of it, cooling slowly in molds, ready to be stripped and rolled into beams or plate or whatever the customer ordered. That's how it worked. Now let's talk about where it worked. Homestead, Pennsylvania, a grimy borough on the Monongahela River, 8 miles southeast of Pittsburgh. In 1907, it's a company town. U.S. Steel owns everything: the mill, the houses, the stores. 3,800 men work at Homestead Steel Works. Most of them are immigrants: Poles, Slovaks, Hungarians, Croatians, Italians. They came to America for the promise of steady work and wages, and they got steady work, all right? 12-hour shifts, 7 days a week, no weekends, no holidays unless the furnace was down for maintenance, and even then, you were probably part of the maintenance crew, rebuilding brick in residual heat that could still blister skin. Every 2 weeks, the day shift and night shift switched, and to make that switch work without stopping production, one crew worked the long turn, 24 consecutive hours. Sunday morning, 6 a.m. to Monday morning, 6 a.m. 24 hours in hell's halfacre. For this, you made $2 to $3 a day, maybe $4 if you were skilled, a first helper, a melter, someone who'd survived long enough to learn the machine's moods, because make no mistake, the furnace had moods. Some days it ran smooth. The charge melted evenly. The chemistry came out right on the first sample. The tap flowed clean. Those were good days. Other days, something was wrong. The regenerator wasn't heating properly. The roof brick was eroding, dropping chunks into the melt, contaminating it. The gas pressure was fluctuating, making the temperature swing. The charging machine jammed, forcing workers to manually clear tons of scrap while the furnace radiated beside them. And then there were the days when the furnace fought back. When you charged cold scrap into a pool of molten steel, you were creating a violent thermal shock, 3,000-degree liquid meeting near freezing solid. The scrap would sink, hit the bottom, and the temperature differential would cause rapid localized boiling of the molten steel. Sometimes it'd spit, a small eruption, a splash of molten metal arcing out of the charging door. Workers learned to stand to the side, never directly in front. But if the scrap was damp, if there was moisture trapped in a hollow pipe, or condensation on a piece of steel that had been sitting in the yard during a rainstorm, or snow packed into a crevice from winter storage, that moisture would flash to steam instantly, and steam expands 1,600 times its liquid volume. You'd get a blowback, a geyser of molten steel and slag and superheated gas erupting from the furnace mouth like a cannon. It didn't happen often, but it happened, and when it did, men died. The engineers knew this, the operators knew this, everybody knew, but the alternative was what? Dry every piece of scrap before charging? Slow down production to let the furnace cool slightly before adding material? That cost time. Time cost money. So you charged it wet, and you hoped. Most of the time you got lucky. August 7th, 1907, the luck ran out. The men who fed the fire. Let's talk about the men. Not abstractions, not workers or labor. Men. Joseph Malady, 28 years old, Slovak immigrant. Came to America in 1902, worked his way from the blast furnace to the open hearth shop. Married. 3 kids. Lived in a company house on 8th Avenue in Homestead. Rent paid weekly from his wages. Made about $2.50 a day as a pit worker. One of the men who handled the ladles, prepared the ingot molds, cleaned slag. He'd been in the mill 5 years. Started as a laborer in the blast furnace, shoveling ore and coke into the skip hoist. Brutal work, but it got him in the door. Eventually moved to the open hearth shop. Better pay. More dangerous, but better pay. His wife had family back in Slovakia. He was saving to bring them over. 3 more years, maybe 4, and he'd have enough. John Kralik, 24, also an immigrant, probably Polish or Czech based on the name. The newspapers didn't bother recording much about him. He wasn't important. Just another body feeding the furnace. George Puskarich, Michael Sedlak, 7 more whose names made it into the August 8th edition of the Pittsburgh Press, misspelled and incomplete. And probably a couple whose names never made it into any record at all, because immigrant workers in 1907 were fungible. When one died, another showed up at the gate looking for work the next morning. These men worked 12-hour shifts in conditions that would violate every conceivable safety regulation today. But in 1907, there were no safety regulations. OSHA didn't exist. Workers' comp didn't exist. If you got hurt, you were done. If you died, your family got nothing. You wore what you brought from home. Leather apron if you could afford it. Felt hat to keep the radiant heat off your skull. Wooden clogs, because wood insulated better than leather and didn't conduct heat as fast. Some men wrapped their faces in wet rags to keep from cooking their skin. Didn't help much. The noise was unthinkable. The roar of gas burners. Imagine standing inside a waterfall made of fire. The crash and clang of charging machines dumping tons of scrap onto brick. The hiss of steam from cooling ladles. The shouts of men trying to communicate over it all. Reduced to hand signals because words were useless. And the heat. We talked about the heat. But let me be specific. The first helper, the man who actually ran the furnace, stood on a platform maybe 6-8 feet from the open charging door. He watched the molten pool, judged the temperature by the color. Orange-yellow meant 2,800 degrees. Yellow-white meant 3,000. White meant you were pushing 3,200 and needed to back off before you melted the roof. No thermometer, no sensors, just his eyes, staring into light bright enough to burn your retinas, in heat intense enough to make your eyeballs dry out and ache in their sockets. He decided when to charge, when to sample, when to tap. If he was wrong, men died. If he was right, the company made money and he kept his job. The melter took the samples, long-handled ladle, reach out over the pool, dip it in, pull back fast. The steel in the ladle would start solidifying in seconds. You had maybe 30 seconds to pour it into a mold before it was useless. Then you ran it to the chemist, got the numbers, ran back, told the first helper, add iron, add manganese, add carbon. Every sample was a brush with death. Lean out too far, lose your balance, and you're in the pool. 3,000 degrees doesn't give you time to scream. You're vapor before you hit the bottom. The charging machine operator had his own nightmare. The machine was mechanical, hydraulic, temperamental. It pushed a buggy loaded with 5, 6, maybe 10 tons of scrap along rails toward the furnace, tipped it, dumped the scrap onto the hearth through the charging door. When it worked, it was smooth. When it didn't, and it frequently didn't, the operator had to get in there with pry bars and hammers and manually clear the jam while the furnace radiated inches away. And the pit workers, the lowest rung, those were the men who died most often. They were in the splash zone. When the ladle tipped and poured steel into ingot molds, if the mold was damp, if there was a crack, if the ladle tipped wrong, molten steel went everywhere. Hit the floor, hit the walls, hit the men. A splash of molten steel the size of a quarter will burn through your boot, through your foot, and out the other side before you can move. A cupful will take your leg off. A bucketful will kill you, and everyone standing near you. This was daily life. Not every day was a disaster, Most days the furnace ran. The men went home tired, deaf, half-blind, lungs full of carbon monoxide, but alive. They'd drink, eat, sleep 6 hours, and do it again. But the maintenance was never-ending. The refractory brick lining the hearth lasted maybe 6 weeks before the thermal cycling and chemical erosion ate it away. Then the furnace had to be shut down. Banked, they called it, and a crew had to go in and rebuild the lining by hand, tearing out the old brick, fitting new brick, all in residual heat that could still hit 200-300 degrees. The regenerator chambers clogged with dust and slag had to be cleaned manually, men crawling into spaces barely big enough to fit, shoveling out debris and stifling toxic air. The gas valves stuck, the charging machines broke, the ladle cranes malfunctioned, leaving 100 tons of molten steel suspended overhead, while workers scrambled to fix the hydraulics before the ladle cooled and locked solid. And through it all, the economic pressure was relentless. Produce more, faster, cheaper. U.S. Steel wasn't paying these men to be safe. They were paying them to make steel. If safety slowed production, safety lost, so the crews cut corners, charged wet scrap because drying it took time, skipped inspections because the furnace couldn't afford downtime, pushed exhausted men through the long turn because stopping meant lost revenue. And the furnace waited. For 6 months after the last serious incident, the Homestead open hearth shop ran clean. No deaths. A few burns, sure. A broken arm when a charging machine kicked back, but nothing catastrophic. The men got comfortable, not careless. You couldn't afford careless around molten steel, but comfortable, familiar. They knew the beast's rhythms. They'd learned to read the warning signs, a change in the color of the flame, a hitch in the gas pressure, a smell that wasn't quite right, except the warning signs only worked if the problem was in the furnace. On August 7th, 1907, the problem wasn't in the furnace, it was in the scrap. 30 seconds in hell. 4 p.m., afternoon shift. August heat pressing down on Homestead like a hand. Inside the open hearth shop, it's 20 degrees hotter than outside, which puts it north of 120. The furnace has been running for 8 hours. The charge is molten, the pool shimmering yellow-white at just over 3,000 degrees. They're ready to add more scrap. Standard procedure. You don't charge the full 200 tons at once. You start with a partial charge, melt it down, then add more to bring it up to capacity. Keeps the furnace temperature stable, keeps the chemistry manageable. The charging machine rolls forward. The buggy is loaded. Several tons of scrap steel, pieces ranging from fist-sized chunks to beams several feet long. It's been sitting in the yard. Maybe it rained recently. Maybe there was condensation overnight. Maybe some of the scrap had hollow sections, pipes, tubes that trapped moisture inside. Nobody checked. Why would they? You'd have to check every single piece, and you're processing tons per hour. You don't have time. The scrap yard at Homestead covered acres. Mountains of twisted metal, old rails pulled from abandoned lines, worn-out machinery from factories, structural steel from demolished buildings. It sat exposed to the weather, rain, snow, humidity. Some of it had been there for months, rust-covered, dirt-filled, and wet. The buggy tips. The scrap slides out through the charging door, tumbles onto the hearth, hits the molten pool. And the moisture, wherever it was, however much there was, vaporizes instantly. Water at 3,000 degrees doesn't boil. It doesn't steam. It explodes. 1,600 times expansion in a fraction of a second. The steam doesn't have anywhere to go except out, and it takes the molten steel with it. The witnesses, those who survived, said it sounded like a cannon, a roar, a concussion you felt in your chest, and then a fountain of liquid fire erupting from the charging door, spraying outward and upward in a glowing arc. Molten steel, liquid slag, superheated gas, all of it moving at explosive velocity, fanning out across the casting floor. The men directly in front of the furnace didn't have time to react. The spray hit them before their brains could process what was happening. 3,000-degree liquid metal doesn't burn you. It vaporizes you. Skin, muscle, bone, gone in seconds. Some of them died so fast they were probably dead before their bodies hit the floor. Joseph Malady was one of them, standing near the ingot molds, preparing for the tap that was supposed to come in another hour. The spray caught him full on. He didn't have time to run, didn't have time to scream, just gone. Others were farther away, 30 feet, 40, far enough that the spray didn't hit them directly, but close enough to catch splashes. Droplets of molten steel the size of marbles, each one punching through clothing, through skin, igniting everything it touched. Men were screaming, running, trying to get out. But the casting floor was a maze of equipment, rails, ladles, molds, and the blowback had sprayed across the exit route. Between them and safety was a lake of molten steel spreading across the floor, cooling from yellow to orange to red, but still hot enough to ignite flesh on contact. John Kralik tried to run, made it maybe 20 feet before a splash hit his leg. Went down. Other men ran past him. Couldn't stop, couldn't help, because stopping meant dying. He was still alive when they finally got to him, burned so badly they couldn't tell where his clothes ended and his skin began. Died in the ambulance on the way to the hospital. Some of them made it, stumbling, burning, blind with pain, but alive. 11 didn't. Joseph Malady, John Kralik, George Puskaric, Michael Sedlak. 7 others whose names were recorded, probably misspelled, in the next day's newspapers. They found some of them where they fell. Others had tried to run and collapsed. The molten steel had burned through them so fast there wasn't much left to identify. You matched bodies to names by process of elimination who didn't show up for the next shift. The ones who didn't die immediately, the ones who caught splashes, who were burned but not killed outright. They were loaded into ambulances and rushed to Homestead Hospital and hospitals in Pittsburgh. Third-degree burns over 30, 40, 50% of their bodies. In 1907, burn treatment was primitive. No antibiotics, no IV fluids, no skin grafts. You cleaned the wound, wrapped it in gauze soaked in saline or oil, gave the patient morphine for the pain, and waited to see if infection killed them. Most of them died within days. Sepsis, shock, organ failure from the trauma. The final count, 11 dead. Another 5 or 6 maimed for life. Blind, crippled, scarred so badly they couldn't work. The Pittsburgh Press ran it on the front page, August 8th. 11 killed in Homestead furnace explosion. The article described the horror, the fountain of fire, the screaming, the bodies. It listed the names, or at least the names the reporter could get from the company, which probably weren't all accurate because immigrant names got mangled in translation. The Pittsburgh Post covered it, too. A couple of other regional papers picked it up. For 2, maybe 3 days, it was news, and then it wasn't. Because industrial death in 1907 wasn't shocking, it was expected. The United States was killing 30 to 50,000 workers a year in mines, mills, railroads, factories. Homestead's 11 dead were a bad day, sure, but not unprecedented, not even close. The killing was constant, relentless, industrial, and nobody with power cared enough to stop it. There was no public outcry, no protests, no demands for reform. The families buried their dead. Joseph Miladi's widow was left with 3 children and no income. U.S. Steel offered her nothing, no pension, no death benefit, no compensation. The company's position was simple. He knew the job was dangerous when he took it. Assumption of risk. That was the law, that was the culture, and there was no recourse, no workers' comp system, no OSHA, no federal safety regulations. You could sue, theoretically, but the courts almost always ruled for the company. The worker assumed the risk by accepting employment. If he didn't like the danger, he shouldn't have taken the job. Never mind that he needed the job to eat. Never mind that every job in the steel industry was equally dangerous. Never mind that the companies controlled the politicians, the courts, the newspapers. The men died, the families starved, and the furnace kept running. 3 days after the disaster, the damaged furnace was inspected, repaired, and relit. By the end of the week, it was back in production. The other furnaces never stopped because the country needed steel, and steel required sacrifice. They don't teach you that in school. They show you pictures of bridges and skyscrapers and railroads and say, "Look what we built." They don't mention the men who were boiled alive to build it, but every beam in every structure that went up in the early 1900s was paid for in blood. Homestead's 11 were just part of the price, and nobody in power cared. The company sent a representative to some of the funerals, not to apologize, not to offer help, to make sure the widows understood there would be no compensation. The company bore no responsibility. The men had accepted the risks when they signed on. Some of the widows took their children back to Europe, couldn't afford to stay, couldn't afford to live in America without a wage earner, packed what little they had, and booked passage on steamships heading east. Others stayed, found work cleaning houses, taking in laundry, whatever they could do to feed their children. The kids went to work young, 10, 12 years old, lying about their age to get jobs in the mill, the same mill that had killed their fathers, because that's how it worked. The mill took your father, then it took you, then it took your sons, generation after generation, feeding the beast. What the dead built, the furnace that killed those men, kept running for another 79 years. Homestead Steel Works operated until 1986. Through World War I, where it produced armor plate for battleships and steel for artillery shells. Through the Depression, where it kept running on reduced capacity while men lined up at the gates begging for work. Through World War II, where it ran 3 shifts around the clock, making the steel that built the Liberty ships and the tanks and the bombers. The open hearth furnaces at Homestead, and thousands like them across America, produced the structural steel that built the 20th century. Every bridge, every skyscraper, every mile of railroad track, the steel came from furnaces like the one that exploded in 1907, operated by men like Joseph Miladi and John Kralik, who knew the job could kill them and did it anyway, because the alternative was starvation. By World War I, open hearth furnaces were producing 70% of American steel. They held that dominance for 50 years. Slower than Bessemer, sure, but controllable, reliable. You could make high-quality structural steel in quantities that would have been impossible a generation earlier. Pittsburgh Steel built New York City. The Woolworth Building, finished in 1913, tallest building in the world for 17 years. Structural steel from Pittsburgh Mills, the Chrysler Building, the Empire State Building, every single one of them standing on steel that came out of furnaces where men died making it. And the human cost? The deaths? The maimings? The men who went deaf and blind and died of lung disease in their 40s? That was just the cost of doing business. It took decades for that to change. Workers' comp laws started appearing in the 1910s. Pennsylvania passed theirs in 1915. The National Safety Council formed in 1913, pushing for voluntary safety standards. Unions fought for better conditions, though U.S. Steel crushed most union organizing attempts until the 1930s. Slowly, grudgingly, the industry got safer. Not because companies suddenly developed a conscience, because dead workers cost money, training replacements, dealing with bad publicity, fighting lawsuits. It became economically advantageous to keep workers alive. But in 1907, that calculus hadn't shifted yet, and the men at Homestead paid the price. The furnaces themselves eventually became obsolete. In 1952, Austrian engineers developed the basic oxygen furnace, the BOF. It did what the open hearth did, but in 30 minutes instead of 10 hours. Better efficiency, lower labor costs, tighter quality control. By the 1960s, American steel companies started replacing their open hearth furnaces with BOFs. By the 1980s, the open hearth was nearly extinct. The last one in the United States closed in 1991. Homestead shut down in 1986, a victim of cheaper foreign steel and an American industry that had failed to modernize fast enough. The buildings were demolished in the 1990s and 2000s. Today, the site is the waterfront, a shopping and entertainment complex. You can buy groceries where men once fed a 200-ton furnace. You can watch a movie where molten steel once flowed. There are plaques, historical markers, a museum down the road that preserves some of the history. But the furnaces are gone, scrapped, melted down, probably, turned into something else, fitting in a way. The only physical remnants of that era are the carry furnaces, blast furnaces, not open hearth, but same company, same era, preserved as a national historic landmark a few miles away in Rankin. You can tour them, stand in the shadow of structures that once made pig iron for Homestead's furnaces, feel the scale of it. But you can't feel the heat. You can't hear the roar. You can't smell the sulfur and metal and sweat. You can't understand what it was like to work a 12-hour shift in hell's halfacre, knowing that one mistake, one moment of bad luck, one piece of damp scrap, and you'd be dead before you hit the ground. The men who worked those furnaces are almost all gone now. The last of them would be over 100 years old. Their children are old. Their grandchildren are middle-aged. But the steel remains. The bridges they built are still standing. The rails they rolled are still carrying trains. The beams they cast are still holding up buildings. Every piece of structural steel produced in an open hearth furnace between 1890 and 1970 is still out there somewhere doing its job. You drive across a bridge built in 1910. You're driving on steel that was made by men like Joseph Malady. Men who knew the furnace could kill them. Men who showed up anyway because they had families to feed and no other options. You look at that bridge and see engineering. I see ghosts. The open hearth furnace was a masterpiece of industrial technology. It solved an impossible problem, how to produce high-quality steel at scale. It built the modern world. It made America a superpower. And it ate men alive. That's the truth they don't put on the historical markers. The open hearth furnace wasn't just a machine. It was a bargain. We'll give you steel, all the steel you need to build your cities and your railroads and your ships. In exchange, you give us men, young men, immigrant men, men nobody will miss. And we took the deal. For 70 years, we fed the beast, and the beast fed us. It built everything, and it cost everything. Joseph Malady was 28 years old when he died. He'd been in America 5 years. He had 3 kids. He made $2.50 a day. He died so that we could have bridges. That's not poetry. That's accounting. And the ledger balanced. We got our steel. He got a grave. The furnaces are gone now, replaced by technology that's faster, safer, more efficient. Nobody makes steel in an open hearth anymore. Nobody has to. But the debt remains. Every time you cross a bridge, every time you walk into a skyscraper, every time you ride a train, you're using something that was paid for in blood. The men who made it are dead. Their names are forgotten, their families scattered, but the steel remembers, and so should we. They don't make them like that anymore, not the machines, and not the men.